Hello everyone, welcome to Easy Ganit. This is Amir Sarvana, and in this video I will be taking questions of coordinate geometry asked in XAT paper from 2008 to 2021. All questions, all previous year XAT paper question of coordinate geometry will be covered in this video. And if you want to learn the theory of coordinate geometry, I'm giving you the link of 5 special classes that I have taken for theory of coordinate geometry. This will help you understand 100% theory of coordinate geometry. All these 5 classes are completely free. Use the given code to watch these free special classes. Now, let's have a look at all the questions. Question number 1, guys. This is a previous year XAT paper question of coordinate geometry. Amazing question. The coordinates of P and Q are 0, 4 and A6 respectively. R is a midpoint of PQ. The perpendicular bisector of PQ cuts x-axis at the point as B0. For how many integer value of S of A, B is an integer? Listen everybody. So first, let's say that guys, this point P, you can see that abscissa of this point is 0 and ordinate is 4. So just take a position here. Let's say this is the point P here and the coordinates are 0 and 4. I see that the point Q here, right, abscissa is A and the ordinate is 6, which is more than this. So can I say this point will be at higher position than P? So let's say this is a point Q here, which where abscissa is A and the ordinate is 6. Now this is a line PQ. It says that R is a midpoint of PQ. Now R here is a midpoint of PQ. Now you should know how to find out the coordinates of the midpoint. Can I say that coordinate of the point R will be A by 2 and 6 plus 4, that is 10 by 2, right? That is 5. You should know how to find out the midpoints. Again, the theory part is explained in the 5 special classes. You can watch all these free 5 special classes of coordinate geometry. Now the perpendicular bisector of PQ cut the x-axis at B0. Now you are taking a perpendicular bisector of this, right? PQ. A perpendicular bisector of this is cutting the x-axis, right? This is a perpendicular bisector, right? That means it will pass through the midpoint. If it is a perpendicular bisector of the line PQ, it must pass through the point R, because R is a midpoint, and because the perpendicular bisector, that means it must pass through the midpoint. Now this is cutting the x-axis at the point S, and the coordinate of this point is given to me as B0. Now we are supposed to find out for how many integer values of A. B is an integer. So guys, the question is about A and B. So I need an equation in terms of A and B, right? You see that the equation of the line RS, I know the coordinates of the point R and S. And can I find out the midpoint? Can I find out the equation of the line? Yes, everybody know that equation of a line is y minus y1 into m into x minus x1, right? Now just put the values here, and m is the slope of the line. What will be the slope of the line? We know that the point PQ, right? The line, the slope of a line, right? The slope of PQ, the slope of the line PQ is y2 minus y1, is y2 minus y1 upon x2 minus x1, right? Here y2 is 6 minus 4 upon x minus x1, that is 0, that is 2 upon a. This is the slope of a line. Now the slope of the line RS, because this line is perpendicular to the line PQ, and two lines, if two lines are perpendicular, the product of slope is minus 1. So therefore the slope of the line RS will be minus a upon 2, right? So just put the value here, y minus y1, right? Let's find out the equation of the line RS. 0 is equal to m, which is minus a upon 2, x minus x1, slope of the line, right? x1, that is b, another point abscissa is b, right? So this is the equation of the line RS, guys, right? This is the equation of the line RS, which is 2y is equal to minus a into x minus b. Now I know that the coordinates of the point R are a by 2 and 5, which will definitely lie on this line, right? Now putting the x as a by 2 and y as 5, 2 multiplied by 5 is equal to minus a into x is a upon 2 minus b. Now this, right, you can see that the point R will lie on this line, right? So you see this, I got an equation now here, which I can write it down as tan is equal to, minus a is equal to a upon 2 minus b. Right, that is okay. This is it. So you see that now a upon 2 minus b will be equal to 10 upon minus a, or can I say that b is equal to a upon 2 plus 10 upon a. Right, this is the final relation you got in terms of x and y, and here you can solve the equation now. Right, now you can easily get the answer. We get to know that b is a upon 2 plus 10 upon a. If I want a and b both to be an integer, you can see that a must be the factor of 10. Yes, a must be the factor of 10 here, because if I want b to be an integer, this part has to be an integer. That means a as a value has to be the factor of 10. So the factors of 10 are 1, 2, 5 and 10. Or you can also take, and because it says that a and b has to be an integer, it does not say that a and b has to be positive integers. I can also take a as minus 1, minus 2, minus 5 and minus 10. But then at the same time, you can see that a must be an even number. If I want b to be the factor of this, a must be the even number because it must be divisible by 2. So the factors of 10 which are divisible by 2 are 2, 10, minus 2 and minus 10. So for these four values of a, b will also be an integer. So if I want a and b to be an integer, the four possible values, and what are these four possible values? 2, 10, minus 2 and minus 10. That's it. This is the correct answer to the question. Moving on to the question number 2 here. Beautiful question of coordinate geometry again. Let's have a look at this one. Given point A is equal to 7, 4, B is minus 10, 0, C is minus 10, 3, D is 0, 10 and E is 7, 7. Every second all the points move by half, making their abscissa half and doubling their ordinate. So every second what you're doing is you're making the abscissa half and doubling the ordinate. This process continues for 500 years. That means, and now there's so many seconds in 500 years. So that means all these points gets, the abscissa of all these points get by half by infinite number of times, and also the ordinates get double by infinite number of times. So you see that the coordinates of A is 7, 4. If the abscissa keeps on becoming half every second for 500 years, it will become half for infinite number of times, right? So after dividing the value of 7 by 2 for infinite number of times, by 2 for n number of times, let's say n are the number of seconds in 500 year, and we know that n is very large number. For very large number, and 7 by 2 raised to power n will tends to 0, because the value in the denominator will keep on increasing the value of n. N is very large number, n tends to infinity here. Now if n tends to infinity here, that means you have a value in the denominator which is very large. So overall the number will tends to 0. So can I say after half 500 years the abscissa will be close to 0, and now you are doubling the ordinate. Now ordinate for 500 years will be multiplied by n number of times, right? It will be doubled for every second. N is very large number, so it will be 4 into 2 raised to power n, right? B here, right? You cannot say that n is exactly infinity, it tends to infinity. It's a very large number, you can say, right? In fact, the better way to say would be n is very large number, right? It's a very large number. So when you have a very large number in the denominator, obviously the overall number will tend to 0. Now B here is minus 10 and 0, right? If I make B half again for infinite for a number of times, again it tends to 0. Abscissa of all these values will be abscissa of all of these value will tend to 0, obviously, right? Now B would be 0 into 0 to power n. C here you can see is minus 10 and 3, right? Again if it becomes half, if it becomes half, again it will tends to 0, right? And this will be 2 power n. D here again, right? D here again is 0, 10, right? Okay. D will again, right, the ordinals of D will become 0, and it is 10 multiplied by 2 raised to power n. Then we have the point E here, right? 7, 7, this, right? After making the abscissa half for 500 years, right? And this for this ordinate has to be double for n number of times. N is the number of seconds, 500 here, which is a very large number. Now I'm supposed to tell which of the two points are close to each other. You see that you should know the distance formula, right? If I have to find out the distance between 2 points where the coordinates are given x1, y1, x2, y2, right? The distance formula says it will be equal to x2 minus x1 whole square plus y2 minus y1 whole square, right? Now see guys, AB, if I want to find out the distance between AB, it would be square root of x2 minus x1 square and plus y2 minus y1 square, right? So this will be 4 into 2 power n minus 0 into 2 power n is 0 itself. This is square, right? So you see that difference is 2 raised to power n plus 2 actually. This is the distance between A and B. Now if I look at the distance between B and C, this again you see that x2 minus x1 square plus y2 minus y1 square, right? So both of these points are actually 0 itself, right? So this becomes 0 itself, right? If you look at A and E now, if you look at the point A and E, so see that we can straight away answer the question here. We can answer the question here, right? Okay, C point is 3. Okay, sorry guys, this is 3 here, not 0. Okay, we need to do the calculation again. So x2 minus x1 square, y2 minus y1 square, 2 power n into 3 minus 1. Okay, x2 minus x1 square and y2 minus y1 square. 2 power n will be taken, 2 power n into 3 minus 1 raised to power 2. Right, this get cancelled. So this will be the distance, you can see here will be 2 raised to power n plus 1. If I want to find out the distance between A and E here, you see that distance between A and E will be again square root of x2 minus x1 square plus y2 minus y1 square, y2 minus y1 whole square, right? This gets cancelled and this is 2 power n, 7 minus 4 is 3. This is 3 multiplied by 2 power n. Then if you look at the distance between A and C, the distance between A and C now is again square root of x2 minus x1 square and y2 minus y1 whole square, right? This get cancelled. This will be 2 raised to power n. Okay. And then we have finally D and E. D and E. You see that D and E difference would be again square root of x2 minus x1 square, y2 minus y1 square. This get cancelled, right? This will be equal to 3 multiplied by 2 power n. Now you see that if I have to see which of these 2 points are closest, you see that the lowest difference, the least difference is between the point A and C, that is 2 power n. All you have to do is compare all these values, right? So the answer to the question will be D option. A and C will have the least distance. Looking at the question number 3 guys, it says let A1, A2, A and be the n points on the straight line y is equal to px plus q. The coordinates of AK is xk, yk, where k can be 1, 2, 3 up to n, such that x1, x2, x3 up to xn are in arithmetic progression. All these values are in arithmetic progression. The coordinates of A2 is 2n minus 2 and A24 is 68 and 31. The y coordinates of A8 is what? Very simple question guys. One of the point that you need to note down here is that values are in arithmetic progression, right? These values are given to us are in arithmetic progression. So this is the second coordinate, right? Look at the abscissa part, right? Abscissa is given to me in arithmetic progression. Let's say that coordinate of A1 are A and B. Now it's given that A2 are 2n minus 2. And then it is also given that A24 is 68 and 31. Can I say that? Can I say that A2, you can see that A2, these values A2, 68, all these values are in arithmetic progression. A2 up to 68 are in arithmetic progression, right? So the first term is A. right? And 68 is a 24th term, right? This is the 20, this is the first term of the arithmetic progression, the second term, and this is the 24th term of the arithmetic progression. Now, can you see that the second term, right, would be a plus d. Arithmetic progression, we know, is a series where the consecutive terms are obtained by adding a constant value to the previous term. So can I say a plus d is 2, and then 24th a plus 23d will be equal to 68. Nth term of an arithmetic progression is a plus n minus 1 into d. Now if I solve these two equations, right, if I solve these two equations, I'll get 22d is equal to minus 66. D will be equal to 3, so A will be equal to minus 1. So abscissa, right, of A1, right? Now we get to know that A1 is minus 1, right? B. A2 is, right, given us 2 as 2 minus 2. A24 is given to us as 6831, right? Now we get to know the first term here, right? Now we know that all these points also lies on y is equal to px plus q. What we are supposed to find out is y ordinate of A8. You're supposed to find out y ordinate of A8. If I look at x abscissa of A8, this would be A8 would be a plus 7 times of d, and let's say that abscissa is y, right? Now this you can see that a plus a is minus 1, d as you can see is 3, so a plus 7d, a plus 7 into d. This is 20, guys, right? Abscissa is 20, ordinate is what we need to find out. Now we know that all these points lies on this line, y is equal to px plus q. So all these points lies on y is equal to px plus q, right? What we have to do now here is, okay, find out the value of p and q, because the moment I get to know the equation of the line, I'll be able to find out the y ordinate, right? In that case, I'll be able to find out the y ordinate. Now guys, I know that this point lies on the line. So in y is equal to px plus q, if I put y as minus 2, x will be equal to 2, which is given to us, right? Similarly, if I put y as 631, a24 is also the point which lies on, a24 as 68 and 31 is also a point which lies on this, right? If I put y as 21, x has to be 68, p plus q. Now solving these two equations, I'll get the value of p and q, right? So multiply the first equation by 34, you'll get it, minus 68 is equal to 68p plus 34q. This is 31, 68p plus q. Take a subtraction, let's get cancelled, right? This is minus 99 is equal to 33q. Q is minus 3, guys, right? Q is minus 3, right? So if q is minus 3, minus 2 is equal to 2p minus 3. 2p will be 1. So p will be equal to 1 upon 2. So we get to know that all these points lies on the line y is equal to px. That means 1 by 2x plus q, and the q here is minus 3. So this is a line. All these points lies on this line. Y is equal to 1 by 2x minus 3. Now we are supposed to find out the y ordinate of A8. I know that abscissa is 20. All I need is the value of y. So in the line y is equal to 1 by 2x minus 3. Just put the value of y. Y is what we need to find out. X we know is 20. Right? This is half. Right? Half into the value of x you can see is a plus 7d. That is 20. Minus 3, 10 minus 7. Now 10 minus 7 is 10 minus 3 is 7. So therefore the y ordinate of this point is 7. This is the correct answer to the question, right? Now in the next question we are supposed to find out the number of points satisfying the above mentioned characteristics. This is the same question, but you're supposed to find out all those points which satisfy the above mentioned characteristic, but not in the first quadrant. So guys, we already know that the line, right, at which all of these points lie is equal to y is equal to half of x minus 3 as for the previous question, right? You can look at the previous question. Now you can see the slope of the line is 1 by 2. That's an increasing line. And when I put x as 0, y will be minus 3. So this line passes through minus 3, right? right? And so this has to be the line, right? Just make a line, right? This is the increasing line. You can see that slope of the line is positive, so this is a line. This is y is equal to 1 by 2x minus 3. Now, out of all the points which lie on this line, we are supposed to find out those points which lies in the first quadrant, and these points must satisfy the mentioned characteristics here, right? What are these mentioned characteristics? Abscissa should be in arithmetic progression and y should be accordingly to these points. Now guys, the first point, as we have found in the previous question, is -1 and b. The first point is, right, x as -1. Now if I put x as -1 here, the ordinate of it would be -1 by 2 minus 3. This would be -7 by 2, that is -3.5, right? So in the given line, if I put x as -1 by 2, right, my first point is, just a minute guys. So guys, x is equal to 1 by 2. X is equal to, we know that the first point that lies on the line is -1 and b, right? -1 and b. Now if I put x as -1, the value of y, right, the value of b, you can say that ordinate of this would be -3.5. So -1 and -3.5 will be the line which will not be in the first quadrant. So can I say that -1 -3.5 will not be in the first quadrant? Why? Because all those points, right, which lies in the first quadrant, abscissa and ordinate both has to be positive. Here both are negative, right? So it will not lie in the first quadrant. If I look at x is equal to 2, if I look at the second point, if, right, x is 2 here, but then y is -2. Again, abscissa is positive and ordinate is negative. So 2 and -2 will also not be in the first quadrant. Now if I look at the point A3 now, we need to find out the coordinates of A3. As we know that abscissa is in arithmetic progression with a common difference of 3. Abscissa would be 5 here, and the ordinate, if I put x as 5 here, the value of y will be 5 by 2 minus 3. That is 2.5 minus 3, which is -0.5. So A3 will be A3, ordinate of A3 will be 5, or will be -0.5. So complete coordinates will be 5 and -0.5. You see that this point 5 and -0.5, again x is positive, y is negative. This point will also not lie in the first quadrant, right? And if I find out the coordinate of A4, you see that A4 would be 5 plus 3, that is 8, and y we do not know. Just put the value value of x as 8 here. Y would be 8 by 2 minus 3. In the equation, this is 4 minus 3, 1. Now you see that here the coordinates of A4 are 8 and 1. Now both are positive. That means A4 will now be in the first quadrant. Now if A4, right, where x is 8 and y is 1, right, lies on this point and it is in the first quadrant. Now if I increase x, y will also go up because it is an increasing line. So can I say all the points which are on the right hand side of A4 or after A4, right, on increasing x, y will keep on increasing. So if x goes up, y also goes up. That means x and y will both be positive for all the points after A4. So these are the only 3 points which will not be in the first quadrant. These points, right, which follow the above mentioned characteristics, right? These are the only 3 points which will not be in the first quadrant. Hence the answer would be C option. Now this question number 5 of coordinate geometry, OABC is a sphere where O is the origin and AB is 1. This is an amazing question, guys, right? Slightly difficult to comprehend, but once you comprehend it, the question is very, very simple. See guys, OABC is a sphere where O is the origin, AB is 1. Okay, so first make a sphere with O being origin here, and the side length, as you can see, is given to me as 1, and OABC is a sphere, right? So just make a sphere with side length equal to 1, right? OABC, right? So the coordinates of this point will be 1, 0. This would be 1, 1, and this will be 0, 1. Now, any point S, which in terms of abscissa and ordinate is represented as x and yi, lies inside the sphere. So S is set of points which lies inside the sphere, such that such that xi plus yi, xi plus yi is less than equal to 1, right? So these are the condition that must be satisfied by all the set of points which belongs to the set S. Now P x1 y1 and Q x2 y2 that belongs to these two sets, right? Be two such points. Two such points, that means it should be the part of S. Now two operation, addition and multiplication on S are defined as P plus Q. When if you want to add P with Q, then abscissa would be defined as x1 plus x2 minus x1 x2, and ordinate will be simply the product of the ordinate value. But if you want to multiply these two, then abscissa will be straight away multiplication, but the same operation that you applied on the abscissa in P plus Q now has to be applied on the ordinate part, right? Now we are supposed to find out for a very large number n, P power n plus Q power n is what? See guys, you choose any point P. You see that P x xi plus yi has to be less than equal to 1. All the points has to satisfy this. If I take any random point P, let's say that coordinates of P are x1, y1. Because x1 plus y1 is less than equal to 1, can I say that value of x1 will be less than equal to 1, as well as y1 should also be less than equal to 1, with the condition in mind that the summation of x1 plus y1 has to be less than equal to 1. Either you take any point or you just try to understand that x1 plus y1 combined should be less than equal to 1. Now guys, if I try to find out the value of P power n. Now what is P power n? P power n is P dot P multiplied by P multiplied by P multiplied by P for how many number of times? N times, as per the given question, right? As per the given question, right? Now, if I want to find out P multiplied by P, now you see that I'm applying the multiplication of this. So x1 and x2 will get multiplied, but in the ordinate would be y1 plus y2 minus y1 y2, right? So guys, if I pick the points x1 into x2, right? So x1 is less than equal to 1, guys, right? So this would be x1 square, right? P multiplied P will both have same coordinates, right? x1 square, and ordinate would be y1 plus y1 minus y1 square, right? This would be x1 square, and y1 plus y1 is 2y1 minus y1 square, right? Now this is x1 square, and y1 can be taken as common, and this is 2 minus y1. Now observe this, guys, right? If I'm having a value which is less than 1, right? If I'm having x1 which is less than 1, then you see that on multiplying n number of values, and it is clearly mentioned that n is a very large number. So a value which is less than 1 and you are multiplying it for a number of times. For example, pick the value of x as 1 by 2. Now if I say what is 2 power n, 1, right, where n is a very large number, obviously you see that this will tend to 0. Can I say that for P power n, where n is a very large number, abscissa will tend to 0? And here y1 is being multiplied by 2 minus y1. Now see that y1 is multiplied by 2 minus y1. Now you see that y1 is less than 1, so can I say 2 minus y1 will be greater than 1? Now if 2 minus y1 is greater than 1 and you are multiplying y1 with a value which is greater than 1, so that y1 will keep on increasing. It will keep on increasing to an extent, but it cannot be more than 1, so it will tend to 1 value, right? y1 keeps on increasing, but then there is a limit on the maximum value of y1, and that can be 1 only. And x1 on being multiplication, because the value of x1 is less than equal to 1, it will tends to 0, right? So P power n will be equal to 0, 1, right? Similarly, for Q power n, the same thing can happen for you can also do the same thing for Q power n also. So for a very large number, right? For a very large number, P power n plus Q power n will be close to. We are not supposed to find it will be exactly 0, 1. It will be close to. It will be moving towards 0, 1 point, right? So therefore, C would be the correct answer to the question, guys, right? Similar to this, we have the next question. So there were two questions on it, right? Here, n is a very large number, but in this case, we are supposed to tell np plus nq will be close to what? Now, guys, see that if I'm supposed to add p for n number of times, right? np is p plus p plus p plus p for n number of times. That means we are supposed to apply the addition operation here, right? So what will happen with the abscissa, right? Now let's say that P as a point is x1, y1, right? Okay, right. So if I talk about x1, y1, P is supposed to be added for n number of times. If P is supposed to be added for n number of times, what will happen? I need to apply the addition operation, right? So again, the same thing, x1, P plus P. If I look at P plus P here only, this would be x1 plus x1 minus x1 square. And then y1 into y1, that is y1 square, right? Now you see that this will be 2x1 minus x1 square, y1 square, right? This is x1 into 2 minus x1, y1 square, right? Now guys, see this. Now I know that x1 plus y1 in total should be less than equal to 1. So now I'm taking a value of 2 to, if x1 is less than 1, can I say that 2 minus x1 will be greater than 1 again, right? So when I multiply x1 with a value which is greater than 1, it will keep on increasing. If it keeps on increasing, right, but the max value is 1, so it will tend to 1. But here you multiply y1 for n number of times, right? Again, this will be happening for n number of times, and a value which is in terms of fraction which is less than 1, if you take that value to power n, this will tend to 0 for very large number of n. So in this case, ordinate will be 10 power 0. So in the case of np plus nq, the coordinates will tends to 1 0. Therefore the answer question will be option B, guys. That would be the correct answer, right? Here's the next question, question number 7. In a plane rectangular coordinate system, points L, M, and O are represented by the coordinates minus 5, 0, 1, minus 1, 0, 5, and minus 1, 5. Respectively, consider a variable point P in the same plane. The minimum value of PL plus PM plus PN plus PO is what? Okay, let's try to see the points here, right? P, you can see here. Okay, in fact we don't need to plot the points in this case. We separate, we know that it's a rectangular coordinate system, and okay, let's make it. P, L you can see is minus 5, 0. X is minus 5, Y is 0. Let's say that is the point P, minus 5, 0, right? And then we have Q, M is 1 and minus 1, X is 1, Y is minus 1. Just take an idea, right? This is L, sorry guys, this is L. Now this point, just a minute. Okay, so this point is L here, and we have a point M here, right, which is 1 minus 1, right? X1, Y minus 1. Then we have X0, Y5. X0, Y5, that is our point now N, right? X0, Y is 5, and O is, for O, X is minus 1, Y is 5. X is minus 1, Y is 5. This is the point O here, right? X minus 1, Y 5. Now if I join all this point, right, you will see this is a kind of quadrilateral, right? It's a kind of quadrilateral that you will have. LM and O, you can say, will form a quadrilateral, right? Now consider a variable point P in the same plane, the minimum value of PL. So we are taking a point P wherever it is lies, right? The question says we are supposed to find out the minimum value of PL plus PM plus PN plus PO. Guys, see this. If I say that this is L, this is M. Now you see that if I take a point P here, now PL plus PM, right? If I want to minimize this, right? If I want to minimize the length of PL plus PM, the point P can be taken here. You can also take the point P here, right? Now you see that in all the cases, if the point P, if you keep on taking the point P closer to LM, the distance, the length of PL plus PM will keeps on increasing. You see that if I take all these points, you see that the PL plus PM will be minimum. It will be minimum if it lies on the line joining the L and M. Yes or no? Or you can say that similarly you take any 2 points, right? Right, because I can see that L and LM, L and N. Okay, this point is N. N is 0M, right? This is N, this is O, right? You can see that L and N are opposite, right? If I want to minimize the length of PL plus PM, right? Let's say this point is n. If I want to minimize PL plus PN, the PL plus PN will get minimized if the point P lies on the line joining the point L and N. So can I say for minimum length of PL plus PN, P should be the P should be on the line joining P should be the P should be on P should lies on the line joining L and N. Similarly, right, look at PM and PO, right? PM and O you can see are exactly opposite, right? Are opposite to each other. M and O, there's a straight line you can take from M and O. Now you see that if P lies here, PM plus, this will be the length of PM plus PO. If P lies here, this will be the length of PM plus PO. But then the minimum length of PM plus PO will be when P lies on the point line joining M and O, right? So can I say P as a point should lie on the line joining L and N and line joining M and O. That means P should be the point of intersection of these two lines, right? In this case, the length of, right, the length of PL plus PN will get minimized. This will be the minimum length, plus PN plus PO plus PM should also get minimized. So the summation of all these value get minimized when P is a point of intersection of the line of these two diagonals, right? So now you see that the length of PL plus PN is nothing but you can easily find by applying the distance formula. So PL plus PN, you see that guys, PL plus PN will be minus 5 minus 0, 5 square, right? X2 minus x1 square plus y2 minus y1 square. This is again 5 square, right? Similarly, PO plus PN will again be PO plus PM. PO plus PM is again distance between minus 1, 5 and 1 and minus 1. Apply the distance formula, x2 minus x1 square 4 plus y2 minus y1 square 5 minus 1 6, 36, right? So this is root 50 plus root 40. Now this is the answer, right? Root 50 plus root 40. You can further simplify it. This is 5 root 2 plus 2 root 10. So the minimum length is B option. B is the correct answer to the question. Question number 8. Two diagonals of a parallelogram intersect each other at the coordinates 17.5, 23.5. So guys, there's a parallelogram here, right? You should know the basic properties of parallelogram if you want to answer this question, right? There's a parallelogram here. The two diagonals of a parallelogram intersect each other at the coordinate. Okay, these are the two diagonals, right? And the point of intersection of these two diagonals are given to us as 17.5 and 23.5. Two adjacent points of the parallelogram are given to us as 5 point. Okay, let's take this as 5.5 and 7.5. The other 2 points are 13.5 and these are the adjacent points. So I need to take it as adjacent point, right? Now find the length of the diagonals. You need to know the property of a parallelogram. The diagonals of the parallelogram bisect each other, right? So that means this point of intersection of the diagonal is nothing but the midpoint. So if I find the length of A to P, I can double it to find the length from A to C, right? You're supposed to find out the length of the diagonal. So guys, the length of AP you can find by simply applying the distance formula, x2 minus x1 square. 17.5 minus 5.5 will be 12 square. X2 minus x1 square plus y2 minus y1 square. 23.5 minus 7.5. 23.5 minus 7.5 would be 16 square, right? 12 square plus 16 square. This is 144 plus 256, right? This would be 400. Square root of 400 is 20. Now that's the length of AP. If the length of AP, so AC will be 2 times of AP, right? That is 2 times of 20. So one of the diagonal will be equal to 40. One of the diagonal will be equal to 40. Now let's the other diagonal. Let's say this is a point P here. So guys, BC, right? The length of BP, the length of BP would be again x2 minus x1, 17.5 minus 13.5, 5 minus 5, 0, 4 square plus 23.5 minus 16, right? This would be 7.5 whole square, right? x2 minus x1 and y2 minus y1 square, right? That's correct. So 4 square is 16 plus 7.5 square will be 56.25. This will be equal to 80.25, right? Now square root of 80.25 would be 9.5, right? Because we know that if a value end with 5, the square of it would be 5 into 5, right? And 9 into 10, sorry, this is 90.25. This has to be, sorry, this is not, this is 72.25, this is 72.25, right? Now 72 is 8 into 9, so can I say that if I have to find out square of 8.5, the last two digit will be 25. 8 into 9 is 72, 72.25. Now this is square root of 8.5. So see that the second diagonal, right, that is BD. Let's say this is BD. Second diagonal BD will be 2 times of 8.5, which will be equal to 17. So 17 and 40. One of the diagonal is 70, other diagonal is 40. 17 and 40 will be the correct answer. D option is the correct answer. That's the last question of coordinate geometry from the previous XAT paper, guys. Let P be the point of intersection of two lines, 3x plus 4y is equal to 2a, 7x plus 2y is equal to 2018. To the point of intersection of these lines, right? Now the line through P and Q has a slope of 2, then the value of A is. This question is actually very easy to solve, but very lengthy in calculation. See guys, take two lines, right? One of the line is 3x plus 4y is equal to 2 times of A. A is unknown here. Then we have 7x plus 2y is equal to 2018. Now P is a point of intersection of these two lines. This is the point P here. Now Q is a point of intersection of another two lines, right? What are these two lines? Again, this is 3x plus 4y is equal to 2018. And here this is 5x plus 3y is equal to 1. Now Q is a point of intersection of these two lines. Now line joining P and Q, this line has a slope equal to 2. We are supposed to find out the value of A. So guys, I can easily find out the point of intersection of these two lines. So I'll get the coordinate of P. Similarly, by solving these two equations, I'll also get the coordinates of 2. Now once I get P and Q, I know the slope of the line that is equal to 2. I will be able to find out the value of A. The question is easy but lengthy in calculation, guys, right? Let's do this. 7x plus 2y is equal to 2018 and 3x plus 4y is equal to 2a. If I want to find out the point of intersection of these two lines, multiply the first equation with 2. 14x plus 4y is equal to 4036. Right. This would be 14x minus 3x. This would be 11x is equal to 4036 minus 2 times of a. X will be 403x minus 2a by 11, right? This is abscissa of it. Now, if I put the value of x, I'll get the value of y. Okay, so I'll get y also in terms of, I'll also get y in terms of x, in terms of a. So just put it here again. 7 times of 4036 minus 2a upon 11 plus 2y is equal to 2018, right? So guys, you need to find out the value of y here, right? I'll just give you the idea, guys. This is complex calculation and there is no other way to reduce this calculation part. So simply find the coordinates of x. And we also know these two lines, right? These two lines can also give me the coordinates of q, right? Now, once I know P coordinates in terms of A, and because Q coordinates will be the unique values, right? There will be no variable in it. I can apply the formula of slope. Slope between, if the coordinates of P and Q are known, then I can apply the formula of slope of the line y2 minus y1 upon x2 minus x1 is equal to 2. Putting this will give you the value of A here, right? The final answer will come out to be 3026. I'm sure you can do the calculation part by yourself, right? It's just a calculation that you have to do. It's a lengthy calculation, complex calculation, right? But there is nothing, conceptual that we can learn much from this, right? You know how to find out the point of intersection of these two lines, and then simply apply the formula of slope to get to the answer as C, guys, 3026. These are all the questions of coordinate geometry of previous year paper of XAT, guys, right, which I have covered in this whole video. To cover your 100% syllabus, right, for CAT and OMTs, you can subscribe to my channel, Easy Ganit by Smith. This will give you the 100% syllabus coverage for CAT and other exams like SNAP, IFT, XAT, right? You can cover your 100% syllabus here. Thank you so much for watching the video. And if you want to learn the theory of coordinate geometry, as you can see that there are chances that you might be getting 1 or 2 questions from coordinate geometry in your XAT paper. 5 special classes which are completely free. All right, I have given you the link of those 5 special classes in the description part of the video. You can refer to those 5 videos, 5 special classes to learn the theory of it. And before you watch those special classes, please use the code sme.yt to access these 5 special classes, guys, right? I'll mention the code in the description part of the video, as well as a link of all those 5 classes to cover the 100% theory of coordinate geometry will also be given to you in the description part. Thanks a lot for joining the session. See you in the next part. Thank you.